Hey, fourth graders, Mr. Crowell here. How you doing? Welcome to my backyard. Not exactly the sunny day I'd hoped for, but not a rainy day either. So today we're going to go over a wonderful book that I believe Miss Icano has started and has wonderfully read. I'm going to do a little portion for you. It's called Anatomy of a Volcanic Eruption, so you may have the opportunity to hear both of us read some of this wonderful book. So have it open. I'm going to be reading starting on page 6, so if you would like to turn to page 6, please get that ready. And while all you are getting onto page 6, I'm going to go over a couple things up on the big whiteboard here. This is lesson 2. Our vocabulary for this chapter 1 is the 4 words are pressure, interior, collide, disruption. My class, you know that when you hear those words, you're going to raise your hands. So if you want to raise your hands when you hear the words, I can't see you, but I know that you've raised your hands. We'll go over them, talk a little bit about them. And then the assignments for this particular lesson is for in your reader-writer journal, which is this one. Ta-da! You will go to page 261 for a reading assignment, and then page 263 for a writing assignment. So very important that we read, we listen, we learn. Let's go do it. Okay, page 6, chapter 1. Here we go. A volatile planet. Earth and its many layers. This is good stuff. Earth, we can see, is a rocky planet covered by vast oceans and plants. That, however, is just a visible part of Earth. The planet is made of layers which vary in thickness and makeup. The crust. The top layer of Earth is called the crust. Earth's crust is made of solid rock. The crust is Earth's thinnest layer. It varies in thickness depending upon location. On the continents, the crust ranges from 19 to 37 miles, 31 to 60 kilometers, in thickness. The crust underneath the ocean can be as thin as 3 to 6 miles. Did not know that. Or 5 to 10 kilometers, depending on which one you want to be working with. Earth's crust is made of large pieces called plates. These plates fit together like a big jigsaw puzzle. Pretty cool. The mantle. The mantle is the layer directly beneath the crust. This layer is about 1,800 miles thick, 22,900 kilometers thick. The mantle makes up about 84% of the volume of the Earth's interior. The upper part, oh my gosh, that is, good job, one of our vocabulary words. Interior. The interior is something that is inside. Or something within. So, Mr. Crowell, can we see it? There we go. So, interior, inside something. The interior of a box. The inside of a box. There you go. The Earth's interior. We're on Mantle. Right there. The upper part of the mantle is made of partially melted rock called magma. The rocks and magma in the mantle move in circular patterns when they are heated and cooled. These movements are called convection currents. Down here, a little text feature. Convection current, circular motion in a liquid caused by heating and cooling. Page 7. Next page over. Core. The core is divided into outer core and inner core. The outer core is liquid. The inner core is solid. The tremendous amount of pressure, vocabulary word, in the inner core squeezes the atoms together to form a dense solid material. The core is about 2,175 miles or 3,500 kilometers thick. Pressure. What is pressure? Pressure is a continuous, Mr. Crowell, a continuous force. Something that is being forced. Pressure is something that is tight and wants to release. Best way I can describe it. And here we have our inner core, we have our outer core. There's the Earth. That's what we're in. If you look up and look around, we're in the Earth. Down here, fact. Scientists can't cut into Earth to find out what it looks like on the inside. One way they can learn about the Earth's interior is by studying seismic waves. These are waves that occur during earthquakes. Page 8. Next page. Where plates meet. The plates that make up Earth's crust float on the top of the mantle, like ships at sea. The plates move because the mantle's rocks are constantly in motion. They don't move quickly, but they move enough to cause changes in Earth's surface over time. Some plates move toward each other. These are called convergent plates. We see a nice big graphic here. Convergent plates, when two plates collide. Vocabulary word, collide. What is collide? Collide is something that what we have, it is something that gets hit and that it then has force to it. So it's a hit with force. Something collides, the ball collides with the bat, comes off the bat, goes. So, when the two plates collide, when they hit with force, the denser one moves underneath the lighter one. That's what happens when an oceanic plate collides with a continental plate. The oceanic plate goes underneath the continental plate. Earthquakes are common at these plate boundaries because of the stress created by the collision. The solid rock of the oceanic plate partially melts into magma as it moves deeper into the mantle. This magma is pushed up into the continental plate and forms a volcano. Many volcanoes are found along convergent plate boundaries. Page 9. And here we see that ring of fire. We over here, there we are. There's Puyallup. For those of you around Puyallup, it's right there. And the Ring of Fire, let's find out about it. Ring of Fire, one of the most famous convergent plate boundaries on Earth, is found in the Pacific Ocean. It is where the Pacific Ocean plate meets with all of the continental plates surrounding it. This area is called the Ring of Fire because more than 450 volcanoes are found there. In fact, 75% of all the world's volcanoes are on land are found in the Ring of Fire. What is the big volcano by us that is on the Ring of Fire? Bing, you did guess it. It is the Mount Rainier, right in our backyard. Can see it over that direction on a nice day. Here we see Mount Fuji is also a part of that Ring of Fire. That is in the country called Japan. Here we go. Page 9. Where plates pull apart. Follow with me. Some adjacent plates do not move toward each other. Instead, they pull away from each other. These are called divergent plates. Divergent plates. When two plates pull apart, they leave a space between them. This space is quickly filled with magma. It creates a new area of land called a ridge. And here we have the bottom of page 10. If the magma pushes its way completely out of the ridge, undersea volcanoes are formed. These volcanoes keep growing taller and taller until their tops are out of the water. These new land formations become islands or island chains. Do you think Hawaii was probably formed that way? I think you're right. Good job. Page 11. Divergent plate boundaries. One divergent plate boundary is found under the Atlantic Ocean. This is where the North American plate and Eurasian plate are pulling apart. Scientists believe that long ago North America and Europe were connected, but after pulling apart for millions of years, they are now separated by a vast ocean. The plates are still moving apart today. The area where the sea floor is spreading is called the Mid-Atlantic Ridge. Many volcanoes are found along the Mid-Atlantic Ridge. The island of Iceland contains at least 8 volcanoes. Can't say that one is a volcano that caused all the disruption. Ding, ding, ding. Last one on our vocabulary words. Let's finish the sentence. Last one caused disruption in air travel in 2010. What is disruption? Well, disruption is a problem. And it is a problem generally connected to an event. So air travel was disrupted because of a volcano that spewed out all the ash and everything into the air, which planes could not go through it. It was a disruption. Last sentence on page 11. It is found on the Mid-Atlantic Ridge in Iceland. Page 12. We're almost done. We're going to page 13. Hotspots. Page 12. Everybody with me? Good. Volcanoes occur where two plates meet. Sometimes they also form in the middle of plates in areas called hotspots. A hotspot is a place where magma rises up through the crust and forms a volcano. If a hotspot is in the ocean, the volcano will eventually grow tall enough to become an island. Over time, a different part of crust will move over a hotspot because Earth's plates are constantly moving. Then a new volcano forms. The most famous example of the hotspot is the Hawaiian island chain. See, you were right. We were right. Good job. Kauai was the first island to form over the hotspot. As the crust moved to the northwest, each additional island was formed. Currently, Hawaii Island is over the hotspot. It is one of the 2 Hawaiian islands with active volcanoes. Eventually, Hawaii Island will move off the hotspot. Another volcano is rising far beneath the surface of the ocean. It is called Luhai, and it is located about 19 miles or 31 kilometers southwest of Hawaii's island's Kilauea volcano. And here we have on page 13, which we're going to stop right here in chapter 1, we have a fact. There's the fact over here. Where's the fact? Mr. Crowell, there's the fact. There's the fact. It says hotspots don't occur on oceanic plates. They also occur on continental plates. Scientists believe a hotspot is what caused volcanic activity in Yellowstone National Park. I went to Yellowstone National Park, and they say there is a pretty old, large volcano that used to erupt millions of years ago. It's hard to believe. Down here at the very bottom of our little, we got a little bit of a caption here. The Hawaiian Islands are volcanic islands that formed over a hotspot. So there you go. So that will conclude our chapter 1. And remember that connected to this reading, we have your reading assignment, which is to go to the Reader's Writer's Journal. It is right here. You are to then go to page 261. 261 should be right here, lesson 2. Lesson 2. The directions are, use each word in a sentence. Interior, pressure, collide, disruption. We've gone over this. Remember, pressure is continuous force. Interior is inside or within something. Collide, when you hit. And then a force is a result. And a disruption, which is a problem connected to an event. Please write a sentence using those words. And then directions. You're going to reread what we just read, 6 through 13 of Anatomy of Volcanic Eruption. Explain how the island chain of Hawaii was formed. Hot spot, moving in and out. Then suggest a visual that might best illustrate how the islands were formed. So you're going to do that right there. And after that, you're going to do the writing assignment, which is going to page 263. 263, directions. Create a diagram of an active volcano. Include labels in a box text to provide additional information about the diagram. Use information from the text to support your answer. You can do that. You can do that. And then down here, relative adverbs. Circle the relative adverb in the sentence below, then write your own sentences using the relative adverbs. Right there, then we're using your writing the ones that you'll write right there. Relative adverbs. Okay, boys and girls, thank you very much. We'll see you next time.